Okay, good afternoon, everyone. Welcome to the video lecture series on Mason's gain formula, part 4. So, what we have seen in the previous lecture is how to draw the signal flow graph. Okay, so basics of signal flow graph. Then we have solved some few problems related to signal flow graph and Mason's gain formula. So, today in this video lecture, we will go for finding the signal flow graph, the overall transfer function, okay, based on the signal flow graph. But in today's lecture, we will not go directly to the signal flow graph, but instead we will go with respect to the given system equations. Okay, so some system equations will be given. Based on that system equation, we need to construct the signal flow graph. Okay, and then after finding the signal flow graph, we will go step by step analysis of the signal flow graph and we'll try to find the overall transfer function. So here, let us consider an example, that is construct the signal flow graph for the following system functions. So here some three system functions are given. So three system functions are some equations they have given. Okay, so based on the equations, we need to go for finding the overall transfer function. You can see here the question here is construct the signal flow graph for the following set of system functions, that is y2, y3 and y4. So four system functions are, so three system functions are given. Okay, and out of these three system functions, they have mentioned that y4 is the output of the system function, but find the transfer function with respect to, that is output divided by input, that is y4 divided by y1. So the very first step here you should observe in the given system function is which is input and which is output. Okay, so for the given system function here, the y1 is input and y4 is output. So how to identify this? Already they have given the y4 is the output, then by defaultly your y1 will be your input to the system functions. Okay, so based on the given system function, let us represent here that y1 is equal to input and y2, sorry, y4 is equal to output of the system function. Okay, so this is the uh, basics which we require before constructing the signal flow graph. We should know which is input and which is output. Okay, sometimes based on the given formula, that is find the transfer function, that is y4 divided by y1, even you can try to understand which is input and which is output. So obviously the transfer function formula is given by, it is the Laplace of output divided by input. So therefore here y4 is output and y1 is input. Okay, so out of this system function, the three system functions, you need to identify the number of variables. Okay, so the number of variables will give you the number of nodes. Okay, so number of variables is equal to number of nodes. Number of variables is equal to number of nodes of the signal flow graph, nodes of SFG. Okay, nodes of signal flow graph. So this is the another important thing we should know before applying the rules or before applying the properties of signal flow graph. Okay, so the basically we have four variables if you count from the signal flow graph. So that is y1 comma y2. Okay, then we have y3 and y4. Okay, so we have four nodes now represented by y1, y2, y3 and y4. Okay, then once you obtain these four variables, try to go for finding the signal flow graph or drawing the signal flow graph individually. Okay, you can do it individually or you can do at a stretch the whole signal flow graph also. Okay, but let us consider equation 1, equation 2, equation 3 separately and try to go for finding the signal flow graph and then combining all the equations to make it one signal flow graph. Okay, so here Let us consider the equation number 1. So equation number 1 says y2 is equal to g1 into y1 plus g3 into y3. Okay, and you should be very careful while finding the signal flow graph that this the LHS side of these three equations are nothing but your output. Okay, so the LHS side here gives you the output of the uh, signal flow graph, or they act as the output node. Okay, so this is nothing but your output. These three are your output nodes. Okay, output nodes. Okay, so y2, y3, y4 and sorry, y2, y2, y3 and y4 are the output nodes. Okay, output node in the sense all the signals like y1 and y3 with respect to equation 1, they should come and meet at a junction point called y2. Okay, similarly for equation 2 and equation 3. So let us check one by one. So consider equation number 1. So in this equation number 1, your y2 is output node. Okay, so just put one dot here and label it as y2. Okay, so what equations, other equations we have with y2? So g1 into y1 and g3 into y3, and y1 and y3 are also node. Okay, you can see the left part of the here. Okay, number of nodes of the signal flow graph. Y1 belongs to the node, y2 belongs to node, y3 is also node, y4 is also node. Okay, but here out of these three, these four, this y2, y3 and y4 are the output nodes. Then which is the input node? The y1 is input node. So therefore just put y1 as one dot here and move towards y2. Okay, and write the coefficient of y1 between the two nodes. You can see what is the coefficient of y1 here. It is g1. So simply write g1. Similarly, okay, so y3 should move towards y2. Okay, so put one dot just beside the y2. Okay, and then drag one line from y3 to y2. Okay, because y2 is my output node at present. Okay, so the coefficient with respect to y3 is g3. So you just write here g3. So in this way we construct the signal flow graph for equation number 1. Okay, now consider equation number 2. Now equation number 2 is y3 is equal to this equation, algebraic sum of these three equations. Okay, but now y3 is nothing but your output node. So if I consider equation number 2, we have three variables we can see, that is y1, y2 and y3. So all these three nodes should come and meet at point y3. Okay, so let us take the graph here. Okay, that is this graph. Okay, or you can simply take this graph also, no issues. Okay, so if you consider this graph, here is the point of y3. So this is y1, y2 and y3. So let us take first variable. So that is y1. Y should start and it should end at point y3. So from y1 I have taken a line, I have dragged and I have kept at point y3. Okay, and whose gain is g4, that is coefficient. Also you can tell, or simply you can tell as a branch gain, it is g4. Now start at y2 and end at y3. Okay, just simply start at y2 and end at y3. Just draw a line and give the name here as g2. Similarly y3. Okay, it should start at point y3 and it should end at point y3. So therefore start at y3 and at the same point y3 and give the coefficient name as g5. So in this way we go for drawing the signal flow graph for equation number 2. Now for equation number 3, here you can see equation number 3 is g6. Okay, is equal to y4 is equal to g6 y2 plus g7 y3. So now the output node is y4. Okay, so you can take it as a point y4 here. You should draw a line from y2 to y4 and y3 to y4. Okay, so from y3 to y4 whose variable is g6. You can see y3, y2 to y4. Then from y3 to y4 whose coefficient again here is g7. Okay, so in this way we go for drawing the signal flow graph. Now you should combine all the graph and draw only one signal flow graph. This. Okay. Now here you can see all the points represented, that is y1, okay, y2, y3 and y4. If you draw the single equations, it is also correct. Or if you want to draw just only one signal flow graph by analyzing all the equations, still it is correct. Okay, so therefore now we have y1, y2, okay, y3 here and y4 here. Okay, so based on the four equations, we have combined all together and made equal to 1. So here you can see how this can be drawn with respect to this signal flow graph. Okay, so now we got the signal flow graph here. So once you get the signal flow graph by combining all the equations, okay, then you should find the forward path. Here the problem again start with finding the forward path. Okay, so to find the forward path here, how to go for finding the forward path is start always your straight line is the first forward path. Okay, so it starts at point y1. Okay, that is right here. So that is the t1. The first forward path is given by t1 is equal to, it start at y1. Okay, then at y2, y3 and y4. Okay, so this is the first forward path. Now the second forward path we may have here is start at point y1. Okay, you can see here it start at point y1. Okay, then go through g4. Okay, reach at y3 and go to y4. This half semicircle and one small line. Okay, so I will write it as y1. Okay, go to point number y3. Okay, and then end at y4. Then we may have more than two also. So here we have one more forward path. Okay, so the another forward path we may have here is it start at y1. Okay, carefully just check the forward path, that is we have at point number y1. Okay, then from y1 to y2. Okay, from y1 to y2. Then from this point y2, a line is going from y2 through g6 and at point y4. So therefore from y2 it goes to y4. Okay, then after the third we have one more, that is represented by t4 is equal to, okay, it start at point y1. Okay, then it will go to point number y2. Okay, point number y2. Then at point number, then we may have at point number t4 is equal to, we have g4, then g3 is here, then we have g6. Okay, this is including this small loop. So from y1 we go to y3, not y2, we go to y3. Then from y3 we come back at point number y2. Then from y2 we go for y4. Okay, we go for y4. We can check. So all the signal flow graph forward path are obtained. I've just written in terms of nodes. Okay, in terms of nodes. You may also write the given transfer function in terms of g values. So let us do that for this particular t1. Let us count now. Okay, you should count the node number with the value of gain represented by g letter. Okay, if I take t1, so that is you start at point y1. At point y1 we have G1, correct? At point Y2, we have G2, right? At point Y3, okay, we have G4, okay, which is ending till Y4, okay, or you can take between Y1 and Y2 is G1, between Y2 and Y3 it is G2, between Y3 and Y4 it is G4. So this I got T1. Okay, so in this way we go for finding the value of T1. Okay, so this is T1. Now once you obtain the value of T1, similarly you can go it for doing it for T2. Okay, so what is T2? Between Y1 and Y3 we have G4. Okay, between Y3 and Y4 we have G7. Okay, so I got the second value of forward path. After finding with this, go for T3. So what is T3? Is equal to Y1 and Y2. We have G1. Between Y2 and Y4, we have G6. Okay. Similarly, for T4, okay, we have between Y1 and Y3, we have G4. Between Y3 and Y2, we have G3. Between Y2 and Y4, we have G6. Okay, we have G6. So in this way, we find the given transfer function values for the given forward path. Okay, so even you can go for doing it into the other mechanism, but this is the simplest way of finding the forward path. Now, how many forward path we have? T1, T2, T3, and T4. So based on the value of T1, T3, T4, find the value of K. Okay. So now the value of K here is equal to how much? It is equal to 4 because we have total 4 forward path. Okay. So after finding the forward path, go for finding the loop. Okay. So how many loops we have? If you see the signal flow graph, we can see the arrow marks are going up and down, okay, coming from backward and forward. But you should only consider those uh, signal arrow marks which are moving in backward direction. Okay, so if you look at this signal flow graph, we have this signal arrow up, that is half semicircle, but it is forward, so therefore it cannot be taken as a loop. Okay, and this down again it is moving towards the Y4, towards the output side, so therefore we cannot take it as loop, so therefore this cannot be taken. And here we at G3 the arrow mark is going towards the point Y2, so therefore that is the first loop. Okay, and here from Y3 to Y3 again it is in the reverse direction, therefore this is the second loop. So basically we have two loops. So let us find the L1. So how to find the L1 here is L1 is equal to, okay, so L1 is equal to, it will start at point number Y2. Okay, see here, this is point Y2, it will go to point Y3, okay, and then come back to Y2. Okay, then coming back to Y2. This is my first loop path. Now the second loop path here is given by L2 is equal to, okay, so L2 is equal to, it start at Y3, okay, and end at Y3 because it is a self loop, because it is a self loop. So you can see in the figure here. So basically we have only two loops, that is L1 and L2. L1 is a minor loop and L2 is the self loop. Okay. Now once you find this L1 and L2 in terms of node, you should go for finding the value of L1 and L2 with respect to the value, with respect to the value of loop gains. Okay, so how to find those values here is, so L1, okay, L1 is equal to, what is L1 is equal to, you should multiply the gain, or simply you can find this Y2, between Y2 and Y3 we have G2, between Y3 and Y2 we have, sorry, this is G2 and this is G3. Similarly for L2, it start at 0.3 and end at Y3. So for that particular number, we have G5. Okay, for that particular we have G5. So we got L1 and we got L2. Okay, so I will just make it more clear that T1 is equal to, what was T1 is equal to? It is your G1. Okay, it is G2 and G7, G1, G2 and G7. Okay, and the T2 is equal to, okay, it is G4 and G7. T3 is equal to, it is G1 multiplied by G6, and the T4 is equal to, it is G4, G3 and G6. So these are the forward path and these are the loops, and we have this. Okay, then after finding the value of forward path, finding the value of K, finding the value of L1 and L2, go for non-touching loops. Okay, non-touching, go for finding the value of non-touching loops. Non-touching loops. How to find the non-touching loops? You should compare L1 with L2. Okay, you should compare L1 with L2. So basically, to find the non-touching loops, okay, none of the loop should match with the first forward path, right? And none of the uh, the loop should touch the other forward path. So basically, how many we have? So we have 3 forward path. Okay, and the value of K is equal to 4. So you will end up with 4 delta functions. Okay, so let us represent, that is, we need to find the value of delta 1. Okay, then delta 2, okay, is equal to how much? Okay, so delta 1 is equal to how much? Delta 2 is equal to how much? Delta T, delta 3, we will let us find. Okay, so delta 4 is equal to how much? So this is the question mark now. Okay, so how to find the value of delta 1, delta 2, delta 3 and delta 4 is, you should compare all the loops with T1 first. Okay, all the loop in the sense, you should check that whether the 2 loops are touching to the forward path 1 or not. So what is the first forward path? It is just a straight line, correct? So it is just a straight line. So therefore here you can see, if it is a straight line, means all the loops are touching. So if all the loops are touching, the value of delta 1 is equal to 1. Okay, because all the loops are touch. Basically, all the loop in the sense, what you should, that L1 and L2, they are touching to this particular T1 graph. Okay, then we have only 2 loops, so we will not fail much of the problem here. Okay, then take the second forward path and take both the loops. Okay, so where is our second forward path? Our second forward path is with respect to T2, that is G4 into G7. So where is G4? G4 is here and G7 is here. So for G4 and G7, we have a touching point at this particular Y3, because our T2 is with respect to Y1, Y3 and Y4. So therefore, both the loops are touching. Again, the value of delta here is equal to 1. So the value of delta 2 is also equal to 1. Okay, then go for finding the value of delta 3. Okay, so delta 3 is with respect to T3. Okay, again you should check whether if you have any loops which are, if any loop they are touching to the forward path. So the third forward path was, it is G1 and it is with respect to G6, this path. Okay, the third forward path was from Y1, Y2 and Y4. So that is the reason we have in the third, T3 is equal to G1 multiplied by G6. So this loop, that is loop number 2, that is G5, is non-touching loop. It is not touching to this particular loop. Therefore, the value of delta here is equal to 1 minus of the second loop. So we'll represent it by L2. Okay, and in turn, this is equal to 1 minus, what is L2? It is G5. It is G5. Okay, So in this way, we got the value of delta 3. Okay. Similarly, go for finding the value of delta 4. Again, in delta 4, you should take the value of T4 and check with both the loops. So what is the path for T4 was, it is G4. This is the upper portion. It will come back to point Y3. It means it is touching to this loop at this node from Y3 to Y2. Now it is touching to my second loop also. Okay. And then coming back to Y4. It means both the loops are touching to the forward path of T4. So therefore, if both the loops are touching, it means my value of delta 4 is also equal to 1. Okay, is also equal to 1. So let us see the value of delta 1, delta 2, delta 3 here. You can check T1, both the loops are touching, therefore delta 1 is equal to 1. T2, both the loops are touching, therefore delta 2 is equal to 1. T3, only G5, that is the self loop is a non-touching loop, therefore we have considered as 1 minus G5. Okay, and with T4, both the loops are touching, therefore delta 4 is also equal to 1. Okay, so all the loops are touching to my forward path. So once you obtain the value of delta 1, sorry, the delta 2, delta 3, delta 4, okay, and then you can simply go for finding the transfer function. But to find the transfer function, you should have the value of delta. Okay, so one more observation in this problem here is we don't have any two non-touching loops. We have only touching loops. Okay, we don't have any two non-touching loops. Okay, so that is the reason we will not go for finding the value of two non-touching loops. Okay, or the three non-touching loops. So we can end up with simple formula of delta. So the delta is equal to 1 minus L1 plus L2. Take the value of these two. So the value of delta is how much now? It is 1 minus what is L1, G2, G3 minus what is L2? It is G5. So this is my value of delta. Then find the transfer function now. So the transfer function is nothing but the Mazins-Gain formula. Okay, so using this Mazins-Gain formula, simply you can go for finding the value of your value of the transfer function. Here is, you can see the Mazins-Gain formula is represented by summation ranging from k is equal to 1 to 4, because we have the value of k is equal to 4. So we take it as 1, 2, 3 and 4. So delta k into tk into delta k divided by delta. So how you can take T1 with respect to delta 1, T2 with respect to delta 2, T3 with respect to delta 4 and T4 with respect to delta 4 divided by whole delta. So simply go on substituting the value of delta 1, sorry, T1, T2, T3, T4 in this formula, and delta 1, delta 2, delta 3 and delta 4 in this particular formula. So if you substitute this value of delta 1, delta 2 and all the values of this, you will find this particular solution. So here we can see the T1 is equal to G1, G2, G7 multiplied by 1. Why it is 1? Because delta 1 is 1. Plus, what is T2? It is G4 into G7 multiplied by again 1, because delta 2 is 1. Okay, then T3 is equal to G1 into G6 multiplied by 1 minus G5. Why? Because here delta 3 is 1 minus G5, plus the T4 is G4, G3, G6 multiplied by 1 again, because delta 4 is also equal to 1, divided by the whole value of delta, that is 1 minus G2, G3 minus G5. So in this way, we go for finding the value of the transfer function, or simply you can call it as overall transfer function for a given signal flow graph. Okay, but you should be very careful in finding the overall value and read the input and output in a proper way, so that there should not be any kind of a confusion with respect to the signal flow graph. So with this topic, I conclude my today's topic. Thank you.